Okay, the starting of the next section, zeros of polynomials. Apply the rational zero theorem is the first objective. And something you need to remember, the zeros of a polynomial, f of x, are the solutions that correspond to the polynomial equation f of x equals 0. And remember we said the zeros and the roots, those are the same thing. And when you're looking at the graph of a polynomial function, the zeros correspond to the, what intercepts? The x-intercepts, right. Now, those are the real zeros of a polynomial. Something I want you to note, the zeros of a polynomial may be real or imaginary numbers. Only the real numbers correspond to x-intercepts. The imaginary numbers, you can't see them. Kidding. It's not that kind of imaginary. But the zeros of a polynomial can be real or imaginary. So an example. I gave you a polynomial function of degree 6. And then I broke it down into 6 linear factors. Do you see the 6 factors? X minus 1, 2x plus 7, x minus root 3, x plus root 3. Those all correspond to real zeros. X minus a real number. 2 of those real zeros are rational numbers, and 2 of them are irrational. What's the difference between rational and irrational? Do you remember? Rational can be written as a ratio of 2 integers, like 1 over 1 or negative 7 over 2. Those are rational numbers. The 2 irrational have radicals. They don't repeat and they don't terminate. Like root 3, pi, those are all irrational numbers. But the real number system is composed of rational and irrational numbers. Those 4 zeros correspond to x-intercepts of that polynomial function. There are 2 more here, x minus 2 plus 3i and x minus 2 minus 3i. Those correspond to imaginary zeros. Those are not going to be x-intercepts. They're imaginary zeros. But something I want you to notice, this degree 6 polynomial has how many total zeros? 1, 2, 3, 4, 5, 6 zeros. That's not coincidental. We're going to talk about that more in a minute. Okay, the rational zero theorem says if you have a polynomial of degree n, and remember that this was just a fancy way of writing the polynomial, right? A number times x to a power. And you keep decreasing the powers of x down to your constant term. So if you have a polynomial of degree n, and you know that p over q, written in lowest terms, is a rational zero. This does not guarantee anything about the irrational zeros, just the rational ones. But if p over q is a rational zero, then p has to be a factor of a sub naught, and q has to be a factor of a sub n. All right, so p has to be a factor of a sub, nope, a sub naught, the constant term, and q has to be a factor of a sub n, the leading coefficient. Yep. A naught is just a number. It's just the last number at the end of the polynomial. It's the number that doesn't have an x attached to it. How's that? Yep. So up here, a naught would have been 273. And a n would be 2. So the rational zero theorem says if you have a rational zero, the numerator has to be a factor of the constant term, and the denominator has to be a factor of the leading coefficient. Let's go see how you apply that. List all possible rational zeros of the polynomial negative 4x to the fourth plus 5x cubed minus 7x squared plus 8. Do you agree that that's a polynomial of degree 4? What is the constant term? The constant term is 8. What is the leading coefficient? Negative 4. So P, what was P? 8. What are factors of 8? 1, 2, 4, and 8. Do you agree? Those are all the numbers that go into 8. Q has to be a factor of negative 4. What are all the factors of 4? 1, 2, and 4. So when we're listing all possible rational zeros, they have to be of the form P over Q So I'm going to take my P, all of my P values, and put them over 1. Okay? So I can get plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, and plus or minus 8 over 1. Do you agree with that? All I did was take 1 over 1, 2 over 1, 4 over 1, and 8 over 1. Now I've got to do the same thing with 2. So I'll get plus or minus 1 over 2, plus or minus 2 over 2, which is 1. It's already listed. I don't need to list it again. Plus or minus 4 over 2, which is 2. It's already listed. And plus or minus 8 over 2. 4 is already listed. Okay, so now I'm going to go do the same with this denominator. I get plus or minus 1/4, plus or minus 2 over 4, which is 1/2, it's already listed. 4 over 4, which is 1, it's already listed. 8 over 4, which is 2, it's already listed. So if that polynomial has rational zeros, it has to come from this list. Those are the only numbers where the x-intercepts could occur if the x-intercept is a rational number. Y'all don't see the power in that at all, do you? It's pretty cool.
Okay, you said it was only numbers that x-intercepts could occur.
If the x-intercept is a rational number.
So all of those are rational zeros?
Those are rational zeros. This is the list of all possible rational zeros of that polynomial. Okay, let's go see how you use that. Find the zeros of that polynomial. Before we go find them, I want to list the list of all possible rational zeros. This is P. So what are factors of P? 1 and 2, that's it. What is Q out front? 1. So what are the factors of Q? 1. The list of all possible rational factors. P over Q. So I get 1 over 1 and 2 over 1. If that polynomial has x-intercepts that are rational numbers, there's only 4 possibilities. 1, -1, 2, and -2. So the next thing I'm going to go do is look at the graph of that polynomial function. Go graph it. Okay, enter the polynomial into my y equals on my calculator. Bless you. Then I go look at my graph. It looks maybe at like -1. Now watch, only because I know what this function does do I know to do this. I'm going to go look at my window and go maybe -3 to 3 on my x's. And on my y's, I'm going to go -1 to 1. What do you notice right here? There's actually 2 x-intercepts, right? But when you looked at the Zoom 6, the Zoom standard, it looked like there was only 1 and that it just went up and touched and came back down, correct? Be careful. All right, so I'm going to check and make sure -1 is a 0 on my calculator. If I hit trace and type in -1, enter, it tells me when x is -1, y is 0. So I'm going to go back over and do synthetic division. I'm going to put -1 in. What are my coefficients? 1, -1, -4, and -2. Go do your synthetic division. Drop it down. 1 times -1 is -1. -1 plus -1 is -2. -2 times the box, -1 is 2. -4 plus 2 is -2. -2 times -1 is 2. -2 plus 2 is 0. Yes, -1 was a 0. So my graph looks something like this. Nope. Do you agree? So right here at -1, that was a 0. Okay, what are those other 2 zeros? Are they going to be rational or irrational? They're irrational because the only other rational had to be 1, 2, or -2. So those other 2 zeros must be irrational. What polynomial corresponds to that? I have x squared minus 2x minus 2. Do you agree? If I set that equal to 0 and solve for x, how could I solve for x? I could use the quadratic formula that says what? X equals -b plus or minus square root b squared minus 4ac all over 2a. So what do I get? 2. What's a? 1. B is -2. And c is -2. So -b would give me 2 plus or minus square root b squared 4 minus 4 times 1 times -2 all over 2 times 1. So that gives me 2 plus or minus the square root of 12 all over 2, which is 2 plus or minus 2 root 3 over 2. If I factor out a 2 up top, I'm left with 1 plus or minus root 3. And now the 2 in the numerator and the denominator cancel, and I get 1 plus or minus root 3. This 0 here is going to be 1 minus root 3, and this 0 here is going to be 1 plus root 3. And remember that this was the only rational 0 at -1. This was a degree 3 polynomial that had 3 x-intercepts. 1 was rational, 2 were irrational.